Hello, welcome to Operations Management. In this lecture, I will talk about product life probability using normal distribution. From your statistics class, you might know a normal distribution looks like a bell-shaped curve with mean in between. So, I will draw a new number line, and this will be a random variable line. And then this would represent the mean mu, and the z-score here would be 0. So this line I will represent with z-score. So this is a standardized score. So as you might know from empirical rule, this would be mu plus 1 sigma, and this will be mu minus 1 sigma. Here mu is the mean and sigma is the standard deviation. Now in our case it will be mostly used with respect to time. So the mean time and the mean standard deviation for the time. So mostly your textbook would say mean life or mean wear out time. So if a product is there, how long it will take for it to wear out, and the standard deviation would be standard deviation of wear out time. Of wear out time. This is for a product. So to calculate z-score, mostly the statistical definition would be x minus mu by sigma. So x in our case we will manipulate this formula to z is equal to t minus mean divided by standard deviation. So you might know this concept. This will be, again, these will be mu plus 2 sigma, this will be mu minus 2 sigma, this is mu plus 3 sigma, and this will be maybe I can extend this, mu minus 3 sigma. So this is this value will be 0, this will be the z-score, this will be 1 2 3 negative 1, this will be negative 2 negative 3. Those are our z-scores. So if you see, that's how in statistics we draw a normal distribution curve. So we will try to solve a problem to understand this concept. So here is our question. The mean life of a certain ball bearing can be modeled using normal distribution with a mean of 6 years and a standard deviation of 1 year. Determine each of the following. The probability that a bearing will wear out before 7 years of service. Question B would be the probability that a ball bearing will wear out after 7 years of service. That is our reliability. And then the service life that will provide a wear out of 10%. So to solve this problem, if you see, we need a normal curve. So because they say it follows a normal distribution. So now I'm solving part A with a mean of 6 years. So this is if I draw a new number line, this would be 6 years. And then they are asking us and a standard deviation of 1. So that means So what would happen is if I move one standard deviation, this would be 7. So they are asking us the probability that the ball bearing will wear out before 7 years of service. So since our mu is mu mean is 6 and standard deviation is 1, this will be, we increase by 1 standard deviation, this will be 7. If they ask you 2 standard deviations, this will be 8, and then this will be 5, this will be 4. That's the concept. But they are asking us 7, and then they are asking us before 7 years of time. So we are looking for an area to the left of this line, which is 7. So I wanted to find my z-score here at this point. So that would be t minus mean by standard deviation. So if I wanted to calculate this, my z-score would be t is before 7 years, so 7 minus mean is 6 years divided by standard deviation is 1, that's 1, so my z-score is 1. So once we get a z-score, we do a probability when z is less than 7. They wanted us to failure before 7. So for this we will use a z table. So it's available at the end of your textbook, but I will also provide this Excel sheet which has z table. Now I'm looking for these the column, the first column is z, so I'm looking for a value of 1, so z of 1. So if you see this one on my column 1, column A 1, so and then you have to go look at 1.00, so that's 1.00 would be 1, so that value is will give me 0.8413. So this value is from our z table 0.8413. That means we have 84.13%. So that means within 7 years the ball bearing will wear out 84.13%. So B, probability that the wear out after 7 years of service. So if we, so this is before, this side was before, and this would be then after 7 years. So if you look at it, the whole probability of this entire area will be equal to 1. So we will do 1 minus, if we do before, probability before, we will get probability after. Or the other way of saying is probability of before plus half probability of after should be equal to 1. So that will be 1 minus p before will be the probability after. So that's it's a simple logic, right? So we will do probability after would be 1 minus 0.8413, which is going to give us maybe 0.1587. So that means there is a 15.87 probability that it will wear out after 7 years. So finally we will try to solve the service life that will provide a wear out of 10%. So now see, when we solve, if I am taking again a normal distribution, so the wear out of 10% would be, this is from the start of the time period, so this area is 10%. So I wanted to calculate first z value, and then we will use z is equal to t minus mean divided by standard deviation. Standard deviation I will write as st. So the first thing is, from this 10%, which is zero point 0.1, I will try to get the z value. So I will go to the our table. Now I will do reverse. So I'm looking for a value of 0.1 in the probabilities. So this is this would be, so it will lie somewhere, I will highlight it with blue. So this will lie, 0.1 will lie somewhere between these two values. So you can either take, so that is negative 1.2 when I go up. So this is if you see this, negative 1.2. So, and then when I go up the column, it might be 2.8 or let me 2.8 or 2.9, whatever you want to take. So let's take negative 1.28 as our z score. So this is negative 1.2, and then we have 8 or 9. So let's take our z value negative 1.28 here. So this will be negative 1.28. T we need to find, mean is given as 6, and then the standard deviation is given as 1. So our T would be 6 minus 1.28, which is 4.72 years. So in 4.72 years there will be 10% wear out of the ball bearings. This concludes my lecture on normal distribution. So we are trying to find product life probability using normal distribution. Thank you.